Hey everyone, Mr. Aaron's. I have this goofy camera that's going to show us how to do some math here, so you can't really see me well right now. But we're going to get into some math today. I hope you all had a great first week of online learning. I'm excited to be in touch with you in person next week. But for this week, this is what you'll see from me. We're going to go over the study guide today, do a couple problems together. If you have any questions about anything, be sure to email me, set up a Google Meet. Those are all awesome things. We have a quiz tomorrow, so today's the day to do that. All right, we're starting with number 2 here. We're doing some converting units. So the way that I always like to set mine up is I always start with my first one. Right here we have 45, and we don't have another unit, so it's going to be 45 feet over 1. And when we are trying to change units, our goal is always to go diagonal. So if I have feet on top, I'm going to put feet on bottom. If I had feet on bottom, I'd put feet on top. That's the easiest way to cancel each other out. So we're trying to convert to yards. So over here I put feet on bottom. I know I can convert that right to yards. They're only a step away. And I know 1 yard is 3 feet. Now that we have feet there, those will cancel each other out. It brings us to yards. Finally, we do our math problem here. We got 45 times 1 is 45. 1 times 3 is 3. 45 over 3 yards is what we get there. That is the same as 15 yards. I put those diagonal from each other. Cancel them out. All right, on to our proportions. We did this last week. So for these, basically the one thing that's important to remember is we are cross multiplying here. Set them equal to each other. So we have 6 times 6 on one side. It's going to be 36 equals 15 times W. It's going to be 15W. Finally, to get W by itself, divide each side by 15. I don't think that's going to be a very nice number for us. It doesn't look like. So I'm just going to leave it as 36 over 15. I'm okay with that. And we're done. Cross multiplied, set them equal to each other. Number 9, same thing. Cross multiply these. We've got 5 times 3 equals 15. On the other side, we've got a little tricky here. This is where we have to set up our distribution. -4 times n minus 5. Take that -4, distribute it out. We got -4n plus 20. We got negative times a negative, becomes a positive. From here, you know how to solve the rest. A couple more steps. Subtract there. We get to -5 equals -4n. Right side by -4. We get 5/4 equals n. Cruising our way through those. Cross multiply strategies you know how to use. Flipping on to number 10. We're getting to that Pythagorean theorem. I got it up here for you if you didn't have it down already. That a squared plus b squared equals c squared helps us find our lengths of right triangles. We're going to use that right now. First, this one's a little different because we are looking at ratios here. We know these are the similar triangles, so they're going to have same ratios. So this one has a ratio of 5.2 to 4.8. This one over here has a ratio of x to 19.2. Check out what we can do here. We'll get to this portion later. We don't need to use it quite yet. Actually, we'll use that until we get to the other side now that I look at it. But what we can do right here, we have those proportions. We're doing a very similar problem to what we were doing on this last page. We set up these proportions over here. We're going to do the same thing over here. Watch what I do. 5.2 over 4.9 is equal to the same proportions. This right here has the same proportions as this does. So it's going to be this is equal to, have set it up the same way. From here we can do the rest. Hit that cross multiply there. Cross multiply there. We're going to get this as 4.8x equals, I'm going to punch this one in my calculator. Now you won't be able to do that, but for the sake of our time here, I want to get you in and out as fast as I can. 99.84. That was because I did 5.2 times 19.2. Finally, we divide each side by 4.8. 99.84 divided by 4.8. And we get x equals 20.8. We look at it. Yeah, that seems like that should make sense. Those are pretty similar proportions there. Checks out. So we're using that formula we were working on, that cross multiply, to find those similar proportions. We'll get into that Pythagorean theorem a little bit later here. Okay, our next one here. We're going to do something similar. We have proportions again. An architect created a small scale of what a college campus will look like once construction is finished. The scale for the model is 2 inches to every 25 feet. The tallest building in the model is 10 inches tall. How tall is the actual building? We don't know that. Look at, we set it up just like we did last one. We're setting up our proportions again. We can do this just like this. That's one of our proportions. Set that equal to the other. These are going to be similar proportions. This is when we're going to use this cross-multiplying method. Cross-multiply here. Cross-multiply here. We get 2x equals 250. Oops. 250 divide each side by 2. Give us x equals 125. Setting up those proportions. Another strategy we could have used there is we could have made this a 1 to 12.5 ratio, converted this down to 1 to 2 divided by 25 is the same thing as 1, 2.5. From there, we could have just multiplied that by 10 for each inch. I like this cross multiply method. Super quick, super easy to set up. I think you should use that one too. All right, here we are. On to our Pythagorean theorem. I got it again here for you. A squared plus b squared equals c squared. We know a is side, and hypotenuse. If you don't know what that means, our hypotenuse is our long diagonal here, not one of the corners that are attached to the right triangle. So we're supposed to figure out if these are sides to a right triangle. So if they are, they should follow this theorem, the Pythagorean theorem. If they are not, then this will not add up correctly in our Pythagorean theorem. So our longest side length is always going to be our C. That's always going to be what we're plugging to C. If we look at down here at this diagram, this side can never be longer than this. These two sides could never be longer than this if it was a right triangle. Our diagonal is always going to be our longest side. So we're going to set this up. I'm going to just start by a diagram. I think that's the best way to do these. 15 here, 20 here, 25 here. Plug that into my formula. We got A, B, and this one has to be C. Either of these could be A or B, but this has to be C. That's our long length. So we got 15 squared plus 20 squared equals 25 squared. I'm just going to punch that one in for the sake of time once again. 15 squared is 225 plus 20 squared is 400 equals 25 squared is 625. That adds up. 625 equals 625. Yes, this first one would be a right triangle. We plugged it into our Pythagorean theorem. We plugged in A, plugged in B, plugged in C, checked it out, worked out. Do the same for the rest of these. Plug them in the same way. Use that Pythagorean theorem right up here. I'm going to write it up again here. Okay, now we're going to use the Pythagorean theorem to find the missing side. Show all the work if it is necessary. Now I remember that what I said is this diagonal is always C. This diagonal is always C. If it's not attached to the right, it's always C. So we got C right here. I'm going to plug that one in right now. Plug that in for C. Now we got A squared. I'm going to say this is A, say this is B. We know B is 40. So I got everything plugged in here. Start to simplify. 40 squared. Punch that in real quick. I know you can do this quick in your head. I'm just trying to go fast for the sake of time. Squared. Okay, now A squared plus 40 squared, which is this, equals right here. Subtract from each side. Simple stuff that you know how to do. That's going to be A squared equals 900. And finally, take the square root of each side. That's going to undo these. Leave me with A on this side. And I can punch this in. Square root of 900 equals 30. Plug that in for my last side length. And check it out by doing 30 squared plus 40 squared equals 50 squared. Check it out. 30 squared equals 900. Plus 40 squared is 1600. Now I want you to notice this here. This checks out. It works. But look at this diagram. This side is a 30. This side is a 40. This side looks longer than this side is. A lot of times when you're doing problems like this, because they don't want to give that away, they don't want you to be able to just guess it, they want you to set it up, and sometimes the side lengths will be misproportioned in the diagram. Don't rely on the diagram too much. Focus on the numbers. Focus on the numbers. Sometimes we get set up, and just because this is looks wrong doesn't mean it's wrong. I checked that, and it clearly works out. Okay, I got a few more for you here. I got 3 more, 2 more. All right, we're looking at our unit rate. Once again, that's us comparing a 1 to something ratio. We have apples are sold in 5-pound bags costing $9.95. That's the proportion. For every 5 pounds, there's $9.95. What is the price per pound? So we need to get this to a 1 to something ratio. So here's what I'm going to do. I want to figure out per pound. How much is X? Set this up. This is our proportion once again. Cross multiply. We've got 5x equals 995. Divide that by 5. 995 divided by 5 equals 199. Another easy way to check this out is you can just simply divide 995 by that 5 pounds. You get 199. Whatever method works best for you, you check out there. All right, last one, we'll send you on your way. We got find the distance formula for the 2 points. Basically what we're going to do here is plugging exactly for the distance formula. We know we got x comma y. We got x comma y. Give myself a reminder. I'm going to say this one's 1, this one's 2. So what I'm going to do is I'm going to plug these in right to this formula. Use this formula. So we got d equals x2 is 7 minus x1 is 3. Here's my x2. Here's my x1. Put them into the formula. Keep that squared there. Plus y2 is negative 3 minus, oops, I didn't mean to put a comma there, minus y1 is 5. Put that squared in. From here we simplify. Start with inside the parentheses. We're doing our PEMDAs. This becomes 4 squared plus negative 3 minus 5 is going to be negative 8 squared. We got the square root of that. D equals, now we got go from here. This becomes 16. This becomes 64. Add those up. We get to 80. So D is going to be the square root of 80. And I don't think that's going to be a nice even number for us. Well, actually, no, it isn't. So we could leave that as D equals the square root of 80, or say that equals 8.944. I'm going to leave it like that. That's that. All right, that's what I got for you today. Finish up that on your own. Use those same methods. Feel free to move around. Email me, ask me questions, and good luck on that quiz tomorrow.